2 point charges, 1 microcoulomb and -1 microcoulomb, are kept at distance of 2 centimeter. 1 microcoulomb and -1 microcoulomb are at distance of 2 centimeter. They form electric dipole situated in electric field of 1 into 10 raised to 5 Newton per Coulomb, with dipole moment making angle of 30° with the field. Calculate magnitude of dipole moment and torque acting on the dipole. What would be the maximum torque? When it would be maximum and how much? So first point, torque at any position is Pe sine theta. So this is 2a into q into E into sine of theta is 30. 2a means distance, that is 2 centimeter. Charge is 1 micro 10 raised to -6. E is 10 raised to 5 and sine 30 is half. 2 I can cancel. So this will become -8 and +5, that is -3 Newton meter. So first part over. Now even P they want separately. P equals to 2aq, that is 2 centimeter into q is 10 raised to -6. 2 into 10 raised to -8 coulomb meter. Then for maximum torque, theta equals to 90 degree. Therefore, P maximum equals to PE. P is 2 into 10 raised to -8. E is 10 raised to 5, which will be 2 into 10 raised to -3 Newton meter. Copy. Okay. Hello. Okay. हाँ. LNT. हाँ. पर HDFC पेंडिंग. हाँ. बस. और दूसरे में देखते हैं. Completed, Aditya?
Sir, is that 2AQ?
Entire 2A is called as distance. 2A. 2A into this is charge.
All right. Okay. One second. Done.
28. Two charges are at distance apart. Okay. Now there is one word given there. Broadside. Two charges plus 2 microcoulomb and minus 2 microcoulomb. That means they form electric dipole. Are at distance of 2.5 into 10 raised to minus 3 meter. So this equal and opposite charges, they actually form electric dipole. Determine magnitude of electric field E. Broad side position means equator. No time writing so that you remember. Broad side means equator. Side end means axis. So broadside means equatorial position, side end means axis position. At a distance of 0.3 from this dipole. At broadside position at a distance of 0.3 from the dipole. If it is rotated through 90°, then what will be the intensity? When rotated through 90° means this is suppose equator, this is dipole, this is equator position. When you rotate this by 90°, then it comes on axis position. So when rotated by 90, that means we want on axis. First meaning follow. Hello?
Yeah, sir.
Say this is suppose dipole. Broadside means it is lying on the equator. On the equator.
Right.
When I turn it by 90, this one, it will come here. No? Then this point will become what? Axis.
Right.
So for axis, you need not calculate because equators double is axis and equator already we are calculating. So in this only important point is understanding or knowing what is broadside and what is side end. Broadside is equator. So I will write at equator, that means broadside. Formula for intensity is 1 upon 4 pi epsilon naught P upon R cube. So this is 1 upon 4 pi epsilon naught to A Q upon R cube. 9 into 10 raised to 9, 2.5 into 10 raised to minus 3, charge is 2 microcoulomb, that is minus 6, R is 0.3 raised to 3 equals to 9 into 218 into 2.5 minus 6 minus 3 minus 9. So 10 raised to 9, 10 raised to minus 9 will get cancelled. Upon 3 cube is 27 into 10 raised to minus 3. 9 into 2, 9 threes are 27. So that will become 5 upon 3 into 10 raised to 3 Newton per coulomb. Answer is not matching, that is what they are doing. Broadside by distance of 0.3 from this dipole. 0.3 from this dipole, so from center 0.3 meter from the dipole. 1.25 into 0.3 1.75. 5/3. Oh. See, charges by mistake I took 2, it is 2.4. Hello? Hello?
You took 2.5, right?
No, no, charge I took as 2. This charge I took,
Right.
so actually it is 2.4. I'm just clearing again everything and writing the proper values. Concept you have followed?
There won't be that big of a difference in the answer, right? Though it's zero point 0.5 difference.
So when it is cube divided, it may not slightly different. So
Okay.
otherwise, we can live with this. You have followed the sum there. 5/3 is 2.66. That is here given. They have given 2 because this is 2.4. So slightly it will increase. Hello.
Yeah, I got that.
Let it be with this. With this charge, this is the answer.
But like this answer isn't wrong, right?
No, no, no. Nothing is wrong. Only value if we substitute, it will be perfect.
Say voice is breaking.
I said nothing is wrong. Only that value by mistake we took 2.4 as 2. That's it. Nothing else.
Right.
Next will come when dipole is rotated by 90 degree, then point lies on axis position. Therefore, E along axis will be double of E along equator. So it will be 2 times 5/3 into 10 raised to 3 Newton per Coulomb.
The answer.
Next one is oral sum. A system has two charges plus 2.5 and minus 2.5 situated on 0, 0, minus 15. 0, 0, minus 15 means x-axis or y-axis or z-axis.
Z.
0, 0, minus 15, 0, 0, plus 15. This means point is where? Z-axis or y-axis or x-axis?
Z axis.
So point is on z-axis, electric dipole is along z-axis. So two charges are equal opposite lying at the point given Find the total charge and electric dipole moment of the system. Chalo, I am doing. If this is z axis, then one charge is QB, other charge is QA. QB is minus 0.25 and QA is plus 2 point. So on the left hand side we have QB because it is positive. Right hand side QA, distance is 0, 0, minus 15 from origin. This is 0, 0, 15 from origin. So total distance between them will be 13 centimeter. Charge is plus 0.25 microcoulomb and minus 0.25 microcoulomb. Find what is total charge. So total charge is QA plus QB. 0.25 minus 0.25 equals to 0. Then what is electric dipole moment? Electric dipole moment denoted by P is finite distance into any one charge. Distance is 30 centimeter, so 30 into 10 raised to minus 2 meter. Q is 0.25 micro, so 10 raised to minus 6. That means this will become 30 into 0.25. 25 into 3 is 75. Then 0 after 2-digit decimal into 10 raised to minus 8. 7.5 into 10 raised to minus 8 coulomb meter. Right. Along z axis.
Done, sir.
Next one. This one, can you try on your own? To charge given, distance given, find dipole moment.
Yep, one,
Just,
sir.
just try. Very simple one. What is the answer?
5 into 10 raised to minus 9
Correct.
kilometer.
This is oral. By looking at that also we can answer. 25th. A stationary oil drop. Stationary oil drop means it is neither moving up nor down. It is at equilibrium. Between two parallel plates has charge of 3.2 into 10 raised to minus 19 coulomb and its weight 1.6 into 10 raised to minus 14 coulomb. Determine electric field acting on the drop. Wait, I am writing W. Since drop is stationary, therefore its weight is balanced by electric force between the two plates. Electric force on charge is QE and weight is given, I am writing as W. So field will be weight upon charge. Weight is 1.6 into 10 raised to minus 14 and charge is 3.2 into 10 raised to minus 19. 16 into 2 is 32. So we get 1 upon 2 into 10 raised to plus 5. That is 0.5 into 10 raised to plus 5. So 5 into 10 raised to 4 Newton per coulomb is electric field. Clear? Hello?
Yep.
Whenever charge drop is stationary, that means the drop's weight is balanced by electrical force acting in upward direction. Hence we wrote this condition for equilibrium.
Right.
Copy 25th. Completed.
Yeah.
Next one. 24. Electric charge plus and minus 100 microcoulomb are placed at distance of 2 meter. Calculate electric field at midpoint of line and at a point at equal distance 4 from each charge. First meaning of this. Charges of minus 1000 microcoulomb and plus 1000 microcoulomb are at distance or are at A and B. A and B at a distance of 2 meter from each other. Distance of 2 meter from each other. Calculate electric field at the midpoint. Midpoint means at a distances of 1 1. Electric field at midpoint of this line AB. And at a point which is equal distance of 4 from each arc. Equal distance of 4 from each arc means it lies on perpendicular bisector. Then this distances will be equal, which is 4 meter from each charge. Done. So first point, intensity at center, this is negative charge, so intensity will be inward, this is E1. Positive charge, it will be outward. Again, two charges are,
The diagram was wrong.
once again I'm explaining, 1000 microcoulomb and minus 1000 microcoulomb at point A and B at a distance 2 meter. Find the intensity at midpoint. So this is positive charge, intensity will be outward. This is negative charge, it will be inward. So therefore intensity at midpoint comma equals to E1 plus E2 equals to 1 upon 4 pi epsilon naught q1 upon this distance, both are same, I am calling r square, plus 1 upon 4 pi epsilon q2 by r square. So this is 1 upon 4 pi epsilon naught. Charge q1 q2 both are same. Since q1 is same as q2, so it will become twice of q1 upon r square. This equals to 9 into 10 raised to 9, 2 into 1000 into 10 raised to minus 6 upon distance is 1 meter square. So it will become 18 into 10 raised to 9 and 3 is 12. 12 minus 6 will become 6, or 1.8 into 10 raised to plus 7 Newton per coulomb. Then they are telling 4 meters from each end. If point is equidistant, it lies on perpendicular bisector, that is called equator. Since point is at same distance from A and D, hence it lies on equator. And formula for equator, hello,
Yeah, I'm listening.
just copy first part. Only a part you copy.
Yeah, just a sec.
Can I clear first part?
Yep.
Second part, they are at same distance of 4 from the two charges. Distance of 4 meter from the two charge. So again, I'm using not dipole wala concept, individual charge. This is Q1 is plus 1000 microcoulomb. So force will be direct, intensity will be directed outward. And for this charge B, because it is minus 1000 microcoulomb, so this will be directed downward. This is 4 meter. Here 4 meter. If it is equidistant, first E1, I can write 1 upon 4 pi epsilon Q1 upon 4 square, and E2 is 1 upon 4 pi epsilon Q2 upon again 4 square. Since Q1 is same as Q2, E1 will be E2. Now my problem is to find what is angle between them, so that I can find resultant. This angle is 90. Hello? This is
Yeah.
4. This is 1. 4, 1. You have to find resultant of these two.
Right. The base is also 4, right? You said equivalent.
Now both are 4, 4. That's for magnitude wise they are same. 4, 4. Q1, Q2 same. E1 is same as E2. So,
Right.
but we are interested in resultant. So we have to find now resultant by using vector. To get vector, we require this angle. So if I take this angle as theta, then E1, when resolved into two components, this will be also theta. Hello? Vertically opposite. Correct? Hello? Hello? Hello?
Sir, you're not audible.
Now? Now also not audible? Now, hello?
Hello. Yeah, now you're audible.
See. This is theta vertically opposite.
Sir, your voice is breaking. It's really loud.
Now it's okay.
Yeah, now it's
See, as I said, this is theta, this will be theta. I selected this because I know opposite side, I know this hypotenuse, so I selected this angle. Now this E1 will have two component, E1 cos and E1 sine. If this angle is theta, even this will be theta. Reason is it is isosceles triangle here, and these two are same. So angle will be same. So E1 we got two, E1 sine, E1 cos. E2 will also have two component, E2 sine and E2 cos. Okay. Hello.
right.
Therefore, E1 cos will cancel E2 cos because they are equivalent opposite. So resultant will be E1 sine theta plus E1 sine theta, E2 sine theta. E1 E2 are same, so 2 times E1 sine theta. 2 times E1 is 1 upon 4 pi epsilon naught charge Q1 upon 4 square. Sine theta is opposite side 1 upon hypotenuse 4. Okay.
Yeah,
So this will become 2 into 9 into 10 raised to 9 into charge is 1000 10 raised to 3 micro to coulomb 10 raised to minus 6 upon 4 square 16 16 into 4 64 2 into 32. Just copy this much. completed. Now direction, can you see it is parallel to this AB final. So therefore I wrote it is parallel to AB.
Yeah.
Hmm? Can I clear? 24th?
Yeah.
23rd. 2-point charges Q1, Q2 are plus zero point 0.2 coulomb and plus 0.4 coulomb are placed at distance of 0.1 meter apart. Find the electric field. Find electric field. First case, midpoint between the two charges. Midpoint between the charges. This is one charge, zero point 0.2, second charge, 0.4, midpoint means center, so total distance 0.1 meter. So this R1 will be same as R2, will be 0.1 upon 2. Because Q1 is positive, so field will be directed outward. Q2 is also positive from here outward. So therefore resultant field at midpoint comma E will be E1 minus E2 modulus, because I don't know who is greater, who is smaller. Actually we can understand 0.2 charge is smaller than 0.4, so E2 will be larger. If that clicks, then you can directly write E2 minus E1, then no need to write that modulus sign, because charge Q2 is greater than charge Q1, so E2 will be greater than E1. If it clicks, you can write directly. If it doesn't, then you will put modulus. So result will be 1 upon 4 pi epsilon naught Q2 upon R2 square, 1 upon 4 pi epsilon naught Q1 upon R1 square. So this is 9 into 10 raised to 9. Q2 is 0.4 coulomb upon R2 zero point 0.1 upon 2 square minus 9 into 10 raised to 9 into zero point 0.2 upon 0.1 by 2 the whole square. Please write everything, draw diagram and copy till this. Yes, completed.
One second, one second.
Mostly in exams, they will ask still easier than this.
Easier than this.
Yes. Now after this, 22 is the exam one. You'll find how simple it is.
The answer.
Second, charges are at same position, but point is different, they are saying. Now I want field at a point on the line joining Q2, Q1, Q2, such that point is 0.05 from Q2. So if this is Q1, this is Q2, the point is 0.05 meter from Q2 and 0.15 from Q1. R1 is 0.15 and from Q2 R2 is 0.05. R1 R2. That means now this E1 is outward this way, E2 is outward. I am finding E1, E2, then I will just check who is greater and subtract. So E1 is 1 upon 4 pi epsilon Q1 upon R1 square. 9 into 10 raised to 9. Q1 is plus 2 coulomb. So plus 2 upon 0.15 square. This is 1.8 into 10 raised to 9 upon 15 square 225 into 10 raised to minus 4. Therefore 1.8 into 10 raised to you can write this as 2.25 10 raised to minus 2. So 1.8 upon 2.25 into 10 raised to 11. That is 18 into 2.25 into 10 raised to 10. Now 2.25, can we write 9 by 4 to make calculation easy? If it clicks to your mind.
Yeah.
So if you can rearrange in that form, then calculation we can do fast. So this is nothing but 18 into 4 by 9 into 10 raised to 10. 9 twos are 18. So we get 8 into 10 raised to 10 as E1 Newton per coulomb. E2 is 1 upon 4 pi epsilon naught Q2 upon R2 square. 9 into 10 raised to 9. Q2 value is given as 0.4. 0.4 upon R2 0.05, which is 5 into 10 raised to minus 2 square. So 3.6 into 10 raised to 9, 25 into 10 raised to 11. Just copy this much, then I'm rearranging again. 10 raised to minus 4.
Done.
So now, because they were directed opposite, we will write resultant is difference E2 minus E1. 144 into 10 raised to 10 into 10 raised to 10 minus 8 into 10 raised to 10. That is 132 into 10 raised to 10. So 1.32 into 10 raised to 12 Newton per Coulomb away. It is in the direction of E2. This was Q1. This was Q2. E2 is towards Q1. Away from Q2 and towards Q1. Answer given there is wrong. They have added the two.
Okay.
Because if you add, then it will become 152. That is 1.52. But we can't add because earlier total distance is 2 meter. From here 0.01 can't be outside. Huh? Hello?
Yeah, I'm listening.
एक मिनट वापस देख लो आप, थोड़ा अपना मिस्टेक हो गया. Because 0.2 ने distance is 1 meter. कितना मीटर दिया है? 0.1 meter. Distance is 0.1 meter and point was 0.15. 0.15 will be outside. Here, outside. So that's why it is E1 and E2 both are same. So you write here plus 152, 1.52. First distance was not 0.2, it was 0.1. If it is 0.1, then our point P is out from both the charges. Therefore, it is added. Reason for adding, I am showing you again in the diagram. This is Q1, this is Q2, distance is 0.1. So point P is at distance of 0.15 means outside, and this is 0.5. So from Q1 positive charge outward, Q2 positive again outward. Therefore we have added and answer will come this away from Q2 and Q1 both. This is the final answer. I did with 0.2, then point will come in between. Because it is 0.2, 0.15 is greater, it is outside. This sum will never come in your exam.
Oh,
Just you will have only the sum of charges between two charges and simple intensity. Now if I do 22, you'll understand why I said this will not come. Can I clear this now?
just making the last diagram. One second. This
Yes.
is the last one for the today, right?
Pardon?
This is last one for today, right?
No, one more we are doing.
Okay.
It is very simple, hardly two lines sum. Whichever sum comes in the exam, they are just max to max 6 lines.
Done.
Done, na? See, next sum I am reading. It is board sum. 2 point charges of 400 and 100 microcoulomb are fixed 60 centimeter apart. Two charges Q1, Q2 of 400 microcoulomb and 100 microcoulomb are kept fixed 60 centimeter apart. Find intensity midpoint of the line joining at the center. At the center means this will be 30 centimeter, this will be 30 centimeter. Positive charge will give intensity always from that point away. So this is E1, this is also E2 away. Now I can say E1 is 1 upon 4 pi epsilon naught Q1 upon R1 square, that is 9 into 10 raised to 9, 400 into 10 raised to minus 6 upon 30 centimeter, so into 10 raised to minus 2 square. This will become 3600 into 10 raised to 3 upon 3 square, 30 is 900 into 10 raised to minus 4. Two zeros cancel. So it is 4 into 10 raised to 7 Newton per coulomb. And E2 will be 1 upon 4 pi epsilon Q2 upon R2 square. 9 into 10 raised to 9 into 100 into 10 raised to minus 6 upon R2, again 30 into 10 raised to minus 2 square. So 9 in 100 into 10 raised to 3 upon 30 square is 300, 900 into 10 raised to minus 4. That means it is 1 into 10 raised to 7 Newton per coulomb. Therefore, resultant intensity comma E equals to E1 minus E2. 4 into 10 raised to 7 minus 1 into 10 raised to 7. 3 into 10 raised to 7 Newton per coulomb. Direction E1 is greater, so it will be towards Q2. E1 is towards Q2, so final answer is towards Q2. If they ask only magnitude, you will stop at 3 into 10 raised to 7. Given field, then even direction you have to write. Okay, completed.
One sec, one. Done.
That's all for today. This Sunday you will write test only on numerical. That too 1 to 7 and 20 to 30. Out of that I will give you any 4. You can write down if you want. Only numerical test 1 to 7, 22 to 30 from this only.